Problem 17 on the book. Fourth derivative minus y equals 0, y of 0 equals 1, y prime of 0 equals 0, y double prime of 0 equals -1, and the third derivative at 0 equals 0. And the problem is find the solution of this problem. Now we don't want you to use your Euler equations or anything of that kind. We want you to use Laplace transform for that. So to answer such a question, first thing to do is to find the Laplace transform of the functions that are involved. Here you have fourth derivative and you have y itself. So you got to find the Laplace transforms. And so, and then we call the Laplace transform of y capital Y of s. Then I can go step by step. The Laplace transform of y prime is s Laplace transform of y minus y prime of 0. And this is s y of s. Y prime of 0 is 0, so this is 0. And the Laplace transform of the second derivative is s times the Laplace transform of the first derivative minus the value of the first derivative at 0. That's how you're applying step by step. That helps you also review the topic on those Laplace transforms of derivatives. So the Laplace transform of the second derivative is s times the Laplace transform of the first derivative minus the value of the first derivative at 0. Sorry, this was minus y of 0 here, right? And y of 0 is 1, not 0. So that's minus 1. And now y prime of 0 is 0. So this is going to be s times sy of s minus 1. That's technically s squared y of s minus s in this case. So if I was to find the Laplace transform of the second derivative, I would find that as s squared y of s minus s. If I want to find the Laplace transform of the third derivative, that will be s times the Laplace transform of the second derivative minus the value of the second derivative at 0. And so that is s, and the Laplace transform of the second derivative is right here. So that is s squared y of s minus s minus, and the second derivative at 0 is minus 1. So that's minus 1 is plus 1. So that's s cubed y of s minus s squared plus 1. And then the Laplace transform of the fourth derivative, which is s Laplace transform of the third derivative, minus the value of the third derivative at 0. And that's s. The Laplace transform of the third derivative is right here. So that's s cubed y of s minus s squared plus 1 minus the value of the third derivative at 0 is 0. So this is s to the fourth y of s minus s cubed plus s. That's it. And of course, here, the right-hand side is 0. So the Laplace transform of 0, in this case, is 0. That's the right-hand side. Therefore, the equation becomes Laplace transform of the fourth derivative. After finding the Laplace transform, we plug them into the equation. And I say apply Laplace transform to both sides. There we will obtain Laplace transform of the fourth derivative minus Laplace transform of y equals Laplace transform of 0. And that gives you s to the fourth y of s minus s cubed plus s minus Laplace transform of y is capital Y of s equals Laplace transform of 0, which is 0. And so you can solve now, and you get y of s equals, this goes to the right, it becomes s cubed minus s divided by s to the fourth minus 1. So this is what the Laplace transform of the solution is. And now you got to find y of t equals the inverse Laplace transform of capital Y of s. 3 steps to that problem, which is inverse Laplace transform of s cubed minus s over s to the fourth minus 1. Now the good news about what we have here in this answer
Doctor, is that s cubed minus s in your numerator?
minus 1. Yes, 2 minus 1 in this case is strange, right? So that's minus s. I wrote minus 1, but it's minus s from here. So we are just copying what we wrote here. And I was saying the good news about this is that clearly we can see that here we can factor out s in the numerator. So that's s times s squared minus 1. And this bottom is s to the fourth minus 1. That's s squared minus 1 times s squared plus 1. And if you don't see that, you're going to start doing partial fractions and do a lot of work that is unnecessary. Here, s squared minus 1 cancels. So you find that it's inverse Laplace transform of s over s squared plus 1. And the answer is cosine t. solution of the problem is y of t equals cosine t. And actually check this to see that if you take 4 times the derivative of cosine t and then do minus y, you're going to have 0. Take 4 times the derivative of cosine t, you get cosine t. Cosine t minus cosine t, you get 0. And then you can check the initial values. Y of 0, cosine of 0 is 1. You take derivative of cosine, you get negative sine. Sine of 0 is 0. You take second derivative, you get negative cosine. Negative cosine of 0 is minus 1. You take third derivative, you get negative, and negative that's plus, you get sine, and sine of 0, it's 0. So you have all the conditions that are satisfied, and the function as well satisfies the equation. Now remember that if we were using the Euler equation to solve this, we would write down the Euler equation for this problem. Have a lambda to the 4th minus 1 equals 0. Write the general solution with 4 coefficients, and then plug in the numbers to solve for the 4 coefficients. That's the whole work we would have to do. But in this case, all you did was turn the Laplace transforms, find the inverse Laplace transform, and that's it. So it really simplifies a lot the problem. Any questions about this? Any question? Okay. So let's say problem 37. This is I'm putting the numbers I'm writing. They are numbers straight from the book. "37 says y prime of t equals 1 minus sine t minus integral from 0 to t y of tau d tau and y of 0 is equal to 0. So this is the problem. And you can see that in this problem, we have derivatives and we have the integral as well. So this is called the integro-differential equation, right? And so we solve the same way we just solved the previous one, remembering what is at stake here. So we say we call Laplace transform of y, let's call that capital Y of s. The Laplace transform of the derivative is s Laplace transform of y minus y of 0. And in this case, it's s capital Y of s. Because y of 0 is given as 0. Then we gotta find Laplace transform of integral 0 to t y of tau d tau. How do I find this Laplace transform? How do I find the Laplace transform of the integral? Madison?
Would it
I'm looking at my notes right now, but I'm not sure.
would it be y of t star 1?
What's that?
Y of t star 1?
That's correct. And it's equal to what?
Did you not hear my response?
I got that. I said that's correct. And then what is it equal to?
Laplace transform of y of t multiplied by the Laplace transform of 1.
Which is?
I haven't got that far. I was just saying my ideas.
What's the Laplace transform of 1?
The Laplace transform of 1 is 1 over s.
1 over s. And this is one of the things that I said you should memorize. The Laplace transform of the integral is 1 over s times the Laplace transform of the function. So that's 1 over s, y over s. Now, you have also Laplace transform of 1, that's 1 over s. Laplace transform of sine t, which is 1 over s squared plus 1. So you find all the Laplace transforms that I needed, and then you apply them to the equation. Apply Laplace transform to both sides. On that left, that's derivative, Laplace transform of derivative, that's s y of s equals, on the right, you go 1, that's 1 over s, minus sine t, that's 1 over s squared plus 1, minus Laplace transform of the integral, and that is 1 over s y of s. That's it. That's how you apply the Laplace transform. Once you do that, the rest is algebra. Solve for capital Y of s. So you bring capital Y of s to the left. You get s plus 1 over s y of s equals 1 over s minus 1 over s squared plus 1. Often what I say is you don't need to combine things when it's written like this. You don't need to find a common denominator on this, because if you do that, you're increasing your workload. You will need to do partial fractions later on. And if they are already separated like this, why combine them? So here, you work on that. That's s squared plus 1 over s y of s equals 1 over s minus 1 over s squared plus 1. And now you get y of s equals multiplied by s divided by s squared plus 1. So you get 1 over s squared plus 1 minus s over s squared plus 1 squared. So this is what y of s is. And now find y of t as the inverse Laplace transform of y of s. And in this case, it's this function plus that one. The inverse Laplace transform of this, that's what you have here. So this is sine t minus, and now this one, there are many ways we can find this answer, the inverse Laplace transform of this. I'm going to use this opportunity to probably do 2 or 3 of them. So the first thing would be look at the Laplace transform of derivatives. Because I look at this and I think this could be the derivative of something that I know. Why would I think that? Because I see s squared plus 1 squared as denominator. That tells me that might be the derivative of a ratio, right? Because the denominator is squared. Now, if I look at the top, that's just s. And the derivative of s squared plus 1, that's 2s. So what is on top there is almost the derivative of what is squared, right? All I'm missing here is 2. So I'm going to say, okay, that's minus. And then I'm going to take this function separately, s over s squared plus 1 squared. This is like 1/2 2s over s squared plus 1 squared. Putting the 2 there to make sure that I have the derivative of the thing that is squared here. And if that is the case, then this is 1/2 of the opposite of the derivative with respect to s of 1 over s squared plus 1. Again, at this point, it is your skills that are at play. Now here, s squared plus 1, the derivative is 2s. So if I know what's the derivative of 1 over s squared plus 1, it is minus 2s over s squared plus 1 squared. That's why the minus shows up, because there was no minus here. Now, if I remember derivatives of Laplace transform, because this is the Laplace transform of sine t. So that's 1/2 minus derivative with respect to s of Laplace transform of sine t. And there's no way you can do this if you have not practiced the topics that were before. Because you need to know that after doing this, what you are getting is a derivative of a Laplace transform, which by a theorem is the Laplace transform of t times the function. So at this point, if I see this, then I know that this thing here by the theorem is the Laplace transform of t sine t. Therefore, the inverse Laplace transform of s over s squared plus 1 squared is going to be 1/2 t sine t. And so the solution of the problem will be y of t equals sine t minus 1/2 t sine t. That's the first way to handle that piece. Now, the second way to handle this would be So this is done, answering that question. So an alternative, finding the inverse Laplace transform of S over S squared plus 1 squared. This would be inverse Laplace transform of cosine t times Laplace transform of sine t. And to do that, you need to know what's Laplace transform of cosine t and what's Laplace transform of sine t. Laplace transform of cosine t is s over s squared plus 1. Sine t is 1 over s squared plus 1. When you multiply the two, this is what you get. And if this is true, then the convolution theorem says that the inverse Laplace transform of the product of Laplace transforms is the convolution of the two functions. So the answer is cosine t star sine t. And now all you have to do is to find that star product. Integral from 0 to t cosine tau sine of t minus tau d tau. Now, if you want to use this method, that's where you will head. And then when you get here, your problem will be knowing how to open the parenthesis here, finding sine of t minus tau, and then computing the integral you get out of there. The problem doesn't get easier. Now, how do we compute this integral? I would say cosine t star sine t. This is a separate problem by itself in this class, finding the convolution of two functions. You would have on your test a question that just said, find the convolution of these two functions. And so here we set integral 0 to t cosine tau sine of t minus tau. Now, how do we integrate this? The good news would be here, to integrate this, I need to know what this is. Sine of t minus tau, what is it equal to? It is sine t cosine tau minus sine tau cosine t. That's the trigonometric formula that needs to be used in this case. So inside this integral, I am going to replace sine of t minus tau by that. It's cosine tau times sine t cosine tau minus sine tau cosine t d tau. Now I can open the parenthesis, sine t can get out, and that's going to be sine of t integral 0 to t of cosine squared tau d tau minus cosine of t integral 0 to t of cosine tau sine tau d tau. So that's what you get when you cross multiply this and remove the parentheses. And now you need to integrate each of these. This one is easy. To integrate this one, you need to know the double angle formula to be able to answer that. So this is going to be sine t integral 0 to t. What's cosine squared tau? It's 1 plus cosine of 2 tau over 2. That's the double angle formula. Minus cosine t. And the integral of cosine times sine, in this case, is going to be sine squared tau over 2. Plug in 0, then t. And this is sine of t. And this integral is going to be tau. I can put the over 2 out. Tau plus 1/2 sine of 2 tau 0 t minus cosine t. And now you plug in t here. That'll be sine squared t over 2 minus, when you plug in 0, sine of 0 is 0. So what you get is sine t over 2. Then you plug in the numbers here. That's going to be t plus 1/2 sine 2t. And then you plug in 0, you get 0, 0 minus 0 minus cosine t sine squared t over 2. And so that is t sine t over 2 plus 1/4 sine t sine 2t minus cosine t sine squared t over 2. And if you just look at this final answer, you might say, come on, this thing is wrong, because we got this. We got that the inverse Laplace transform of that thing is 1/2 t sine t. And now we are finding out that it's 1/2 t sine t plus 1/4 sine t sine 2t minus cosine t sine squared t over 2. So what's wrong? Am I lying in the initial one of these solutions? The answer is no. This whole thing is 0. So it's basically the same answer. Like I said before, no matter what is the method that you choose to answer the question, you will end up with the same answer. And why is this thing 0? Because sine 2t, this is 1/4 sine t, and sine 2t is 2 sine t cosine t. And that's going to be minus cosine t sine squared t over 2. And the 2 cancels here. That's 1/2 sine t, that's sine squared t cosine t minus 1/2 cosine t sine squared t. And this is, as I said, 0. So the whole thing is just t sine t over 2. Any questions? Is there any question on this one? All right. If there is no question, then let me ask you to help me solve this one. And 33. F of t plus integral from 0 to 1. I'm sorry, 0 to t. F of tau d tau equal 1. Anyone with something to share?
You take the Laplace transform of f of t, which is f of s,
Okay.
and then you take the Laplace transform of the integral,
Mhm.
which would be 1 over s times f of s.
Mhm.
And then you take the Laplace transform of 1, which is 1 over s.
Correct. Now you got to solve this. So you get s plus 1 over s, f of s equals 1 over s. So you find f of s equal 1 over s plus 1. And what is f of t here?
Is e to the negative t.
Excellent. That's it. Just as simple as that. And again, the method is simple. Take Laplace transform, do the algebra, take the inverse Laplace transform. And the only question is, do you know your functions? Any questions? Okay. Let me ask this. Use the convolution theorem to answer. A, let's say find the inverse Laplace transform of one over s plus 1 times s minus 2. Giving you 2-3 minutes to do that. All right, anyone with a proposition? What's the first step here? Daniel?
Well, I split them up right away. So it's Laplace transform of 1 over s plus 1 times 1 over s minus 2. So I split them up.
That's the step, okay. And then?
And
It's gonna be e to the negative t star e to the 2t.
First, that's the step you need to show. And then this is product of Laplace transforms. So the inverse Laplace transform by the convolution theorem is e to negative t star e to the 2t, which is equal to integral 0 to t of e to negative 2 tau times e to the 2 times t minus tau d tau, which is integral from 0 to t e to the 2t minus 4 tau d tau. And this is equal to minus 1/4 e to the 2t minus 4 tau, plug in 0 and t. When you plug in t, that is minus 1/4 e to negative 2t minus, when you plug in 0, minus minus becomes plus 1/4 e to the,
Is it 3 tau or is it
yeah,
4 tau?
it's that's the problem here. That's just negative tau here, not negative 2. And so that's going to be negative 3 and negative 3 tau, and this is 1/3. And right there in the answer, you see the problem coming. When there is a mistake. And so when you plug in t, you got negative t. So that is negative 1/3 e to the negative t plus 1/3. And then when you plug in 0 here, you got e to the 2t. So that's 1/3 e to the 2t minus 1/3 e to negative t. That's it. And that's it for me today. If you have a question, you can ask. If there's no question, then I see you on Monday.